Hello, everybody. I hope you can, hear me all right. I need to- I'm such a bad streamer. I need to change my real life sign outside my room to say that I'm live. Enjoy the calming sounds of jet engine fans. Actually, I think my mic maybe my live reaction to this. Oh my gosh, hi! Hi, Umbra. I know I'm back. I probably sound like garbage. A lot less sound dampening in this room, but we're gonna be doing like physics and math and stuff because I have to do them, which is like so fun and cute. And of course, Storm's gonna be like asleep. You gotta BRB so I don't die. I'll BRB as well, so I need to just change my real life sign outside my room. One sec. Hey, I'm back. Alright. The physics engineering class is crazy. Oh, bro, I'm taking a physics engineering class. It is easy. But it's just mine. We're gonna do some problems from that one first, actually. So, if you're in my physics class, I'm gonna have to ban you. But it's fine, because no one's in my physics class. Right? Right? Don't say anything else. If you are, okay? Don't copy my problems and we're fine. Okay, I gotta find what we're doing. So, let me give you a breakdown. I'm not on the East Coast either. I'm in California for school. So we are doing... Oh, I forgot. It's actually an assignment. It's not in a textbook. Although we could do some textbook stuff if you all want. I have a pretty good PDF, but... I'm not. Surely clueless. Umbra, if you were in my class, that'd be awesome. Okay. Oh no, I need my Alt-Tab. I actually have a second monitor, so if you see me looking this way, it's because I'm looking at chat. I still need to get a mic arm. I wish. My professor is bad. My professor is cool. I think it's just annoying because I've done this stuff, like, a lot. Because I had to... For my Physics 2 class, I took 2 years of physics. My Physics 2 class, we did a lot of Physics 1 again because people hadn't taken Physics 1. This is like the third time I'm doing it. Okay. Yeah. So I'm gonna just like shrink this down a little bit. It's gonna change it on stream, but I'll change it on stream as well. Real quick. You know, at least get it a little bit centered. Okay. So, where's my mouse? Oh god, this is gonna be so hard. Alright, so we're just gonna do some- we're gonna start with everybody's favorite physics thing. Unit conversions. Okay, 60 miles an hour. Oh my god. I need to- let me, sorry, let me change my tablet controls, like, real quick. I need to set one of these to Alt-Tab. This can be... keyboard, keystroke, Alt-Tab. Did it just Alt-Tab me out of it? Oh my god, stop it. Please. Oh, Alt-Tab, there we go. Did it change it? Let's see. Let's see if I can Alt-Tab with this. Nope. Awesome. I love Wacom so much. It's so awesome. Okay, I'm so pissed. Sorry. I know, not a good start to the stream, right? But like, I just have been trying to get my computer to work, and it just has not been doing it. It has not been doing what I want it to do. And it's really not awesome of it, not gonna lie. let's see. Does it alt tab now? Okay, no, it does. Oh, it's because I'm pressing the wrong button. Oh god, I'm so smart, guys. I'm an engineering student, I swear. Okay, it alt tabs, let's go. We've been learning a lot of vector calculus. Both of my calc 3, 4 have a lot of vectors. I've been doing some vectors. I don't know why this is so we need to go to feet per second, right? Pretty easy. So we have 60 miles over 1 hour. And there is 1 hour over 60 seconds. And there is a mile into feet is 1 mile. Oops. 1 mile on the bottom here. 5280 feet to 1 mile. I need to buy a new calculator, which I'm not looking forward to. This and this cancel. It is 5280 feet for 1 second. That's wrong. Wait, an hour does not have 60 seconds in it, 60 minutes. Oopsies. Oh god, oh god. I'm smart, chat. I'm smart, I'm smart, I'm smart. Okay, I'm so smart. I did the exact same thing earlier today. Oh boy. 1 minute. 60 seconds. 5280 feet and 1 mile. So we have this will cancel, this will cancel. Obviously these. Oh, yeah. I'm like, what is happening? Okay, yeah, they all cancel. So we have 5280 feet over 60 seconds equals, cross these out, 528. I'm just gonna use my phone. How's the audio mixing? How does it sound actually? Does it sound bearable? Is something massively wrong? 88 feet per second. That seems like way more, right? I don't know why this is so, like, weird. Maybe if I try a different marker. Oh, that one sucks more. I don't have any of my clip settings set up on this computer. What is this? Oh, flat marker. I thought it said wrap marker. Okay, that's not gonna work. I mean, we can use something like this, but like, oh, it's so fat. Get rid of this. I don't need to see this. Sorry. This is probably the most scuffed Damie stream you will ever see. I didn't even have any of my starting screen images. Ugh. This tool property needs to be much larger, and this needs to be much larger. Thank you. Okay. Alright, that's problem 1. What's next? That's A. The acceleration of a freely falling object is 32 feet. Use this to express the acceleration in meters per second squared. So we have feet per second squared, and we're going to meters per second squared. This is A. This is B. So we have, what was it again? It was 32 feet per second squared. We want to go to meters per second squared, so we could do feet to meters, but I know inches to centimeters, so we'll just do that one. 1 foot, 12 inches, times 2.54 cm, 1 inch, times how many centimeters are in a meter? 100. Oh, nice. My pen is cutting out even. So awesome of it. We don't need to get rid of the second squared part, so we don't need to square any of our measurements, which is really nice. So we've just got, you know, 32 times 12 times 2.54 over 100. Nope, the cm goes on the top. The meters goes on the top. Second squared, meters. See what that is. So 32 times 12 times 2.54. That is angular speed. Oh yeah. That's like the theta stuff, right? I haven't done angular velocity in like 2 years. I'm just gonna divide this by 100 real quick. So this is 9.75. And he just wants 3 sig figs, so yeah. We gotta box the answers. We gotta be the good students. Box the answers. Nice. Easy. Okay, C. What have we got for C? Okay. The density of water is 1 gram per centimeters cubed. We want kg per meters cubed. Okay, so 1 gram per cm cubed. So kg, 1,000 grams are in a kilogram. And then centimeters cubed to meters cubed. So we know we can do 1 cm, or sorry, not 1 cm, 100 cm over 1 meter, and then we cube this. And that'll get us our little thing. So this has got 3 zeros, this will have 6. We can just kind of do like this is 10 to the third. No, is it 10 to the third? Am I stupid? Yeah. This is 10 squared, so this will be basically 10 to the 6th over 10 to the third equals, sorry, I should put the units, kg over meters cubed. So we'll just say, wait, grams per centimeters. Is that would be 10 to the third kg per, wow, okay, my pen is just shorting out. Technical difficulties here today, folks. Okay, is that right? Let's see. So, let's see, I'm just gonna check this one. 1 gram per centimeter cubed equals 2 grams to meters cubed. Gram per cubic meter, but we want kg per cubic meter, so you take this number and you do 1, 2, 3, and yeah, you get 10 to the third. Okay, poggers. All right. While driving in a foreign land, you see a speed limit sign on the highway that reads 180,000 furlong per fortnight. Oh my god, dude, we got fortnight problems up in here. 180,000 furlong per fortnight. I'm gonna spell fortnight like fortnight, I'm sorry. So a fortnight is, how much is a fortnight? A fortnight is 14 days. So we'll do the fortnight first. 14 days. And what are we trying to go to? Like miles per hour? Like what are we feeling? How many? Yeah, miles per hour. And then 1 day is 24 hours. Okay, so that gets us into hours. And then a furlong is 1/8 of a mile. So 1 furlong, or 8 furlongs equals 1 mile, I should just say. Right? Because you just move the 8 down. And then we want, yeah, miles per hour, so that's great. And I guess we can kind of think about this in our brain to see if it's a highway speed that would exist. So we'll do 180,000 divided by 14 divided by 24 divided by 8. 66.9. So 66.9. I'm gonna do 9.6. Miles per hour. That's not how you write miles per hour, but you know what? Whatever. Okay, oh, I forgot to box this one in. Wow, that's a bit of a bad box, isn't it? I'm not used to this new screen size because I have 2 monitors and it stretches across both monitors. I'm in the big leagues now. I got my 2 monitors. One is a laptop screen. I hope you can hear me. That's the only hope I have. Okay. Anyway. A certain fuel-efficient hybrid car gets gasoline mileage of 55 miles per gallon. Okay. 3. Lovely, wonderful. So we want to go 55 miles per gallon to kilometers per liter. So 55 miles per 1 gal. So if we want to go gallon to... Oops, I just closed my tab. Wow, awesome. Good job, Damie. There we go. Okay, I don't know the conversion from gallons to liters, but I think that's a pretty good one to know, so let me look that up. Gal to liter. Ooh, that's not great. I mean, it's about 4, but like... Oh. What do you think, chat? What else could we do? Gallon to, like, ounces? Nah, I feel like gallon to liter is, like, pretty normal. We'll do that then. So 1 gallon is 3.785 liters. And then we want to go miles to kilometers, so we can do the crazy long thing, which is just, you know, 1 mile is 5,280 feet. And then we've got, you know, 1 foot equals 12 inches. And then 1 inch is 2.54 centimeters. And then, I don't know, we'll just do 100 cm to 1 m. Because I'm, like, lazy. and then 1 m to how many in a mile? A kilometer, 1,000. Let me fix that. 1,000 m in 1 kilometer. We got all that. Look at all that. So we'll do the first half first, as you do. 55 times 5,280 times 12 times 2.4 is going to equal this large number, and then we'll divide that by the 0.3 that thing, then divide that by 100, then divide it by 1,000. And that gives us 23.38. Oh, that's too many sig figs. 385. Oh, I keep getting ones that I... 0.4. What do we have? Per liter. Is that a normal number? Let's see. I feel like it might not be. Normal for car. 9.3. What do we get? 20. Oh. 23? But like, what about miles per gallon? Around 25 miles a gallon. Okay, never mind. Then it's doubled. So yeah. Like about, right? Okay, cool. We're not we're not completely off track here. Okay, A, and then we'll do part B, which is... So long problems. Well, if they're not long, there's a lot of them. If this car's gas tank holds 45 liters, how many tanks of gas will you use to drive 1,500 kilometers? Okay, so we have... Okay. So we have 1,500 km, which we know that we can go... we want to see... If we know that we can go... how many km in 1 mile? We can go with 23.4 km. Sorry, km per liter. For 1 liter. And the gas tank can hold 45 liters. Right? So this will tell us... Wait, no, that cancels out the liters. We want to know how many... No, this will give us a number. Right? So... If we want to know how many times you can go this many kilometers on 1 liter... Wait, let me think. That'll give us liters. Yeah, this will give us the right answer. Sorry for like the boring stream. We're gonna do parametrics later though. And also I just need to get this done. So I was like, you know what? Why don't I just stream it, right? Divided by 45. 1.4? 1.42? That doesn't sound right. Can you- oh, can I explain the XYZ plane? Hello? Am I still live? Am I dropping frames or something? Are we going? What's happening? Anyway, in case I am still live, let me explain this. So, basically, we know about X and Y, right? We know about the Cartesian plane. That's not a problem for us. We know them, they're our good friends. So we have this, right? And this is our X, this is our Y. But let's say we want to describe things in the real world, right? We're not a flat people. So generally people make a third axis called the Z-axis. And sometimes you'll see different drawings of it. So like sometimes people will say, this is X, this is Y, this is Z, like sort of out of the page. In physics, you tend to say the Z-axis is out of the page and you mark it as like this is going out at you. And if you use an X, then it's going into the page this way. Like you see the butt end of it a little bit. But sometimes it can go up like this, right? This is just another representation. Like if this is the table, basically, then it's coming up out of the table, and this is like if this is the table, you know? So it's not too bad. It's a little bit hard to wrap your head around when you're doing something like, let's say you have a vector, right, that would normally be from like here to here. Like that's not too hard. Like here, let's draw it in this one as well. Like this vector right here, right? But this vector, let me see if this audio is working now. Gonna load audio? No? Gonna load my stream if I play my stream? Oh, do I have sound? Am I just like not slaying right now? I don't know. Can I play any sound? Scuffed, you know how it be. Let me just make sure I'm not like... But yeah, you know, sometimes you have a vector, but sometimes you can have a vector, right? Like if you have 3 coordinates, sometimes that vector can go up, right? So if you have your, let's say it's 1, 1, 1. This is your X, this is your Y, this is your Z. So if you find it hard to visualize things in 3D space, then it might be a little bit hard to visualize. But if you can understand that, if you can kind of see it in your brain as like a little desktop, like if you're like on your tabletop, that might help a bit. Just gonna put that in there for now. Let me see if something else loads. Let me make sure my internet is not like actually breaking. No, okay, it loads. It's just okay. Thank God. All right. I'll just reload this page then. Let me close some stuff though. Just maybe try and help my computer out like just a little bit. No, okay, it's still loading. Anyway, yes, vectors can be confusing. I'm gonna listen to you make cat noises while I put together my new chair. Meow, 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 meow. That sounds awesome, by the way. I love building stuff. This, on the other hand, is not awesome. What am I thinking of? Okay. I need to figure out how many tanks of gas this is. If we can go to 3.4 kilometers for every liter of gas, right? So 23.4 for every liter. And let's say we can go 45 liters, right? That's 153. 1,053. So that's actually, maybe our answer is good then. Because if this is one tank, right? Because we want to get tanks. That's 1,500 divided by 23.4 divided by 45, which is, yeah, about 1.5. So 1.42 tanks of gas. My professor is a little strict about how we write our units, I think. So I'm going to put tanks of gas, even though I would normally never write that. I would just probably write tanks, but you know. So yeah, if you want me to explain more about if there are any specific like vector questions you have, like I can totally help you out with those. Wow, my thing is really not helping me out today. A lot of things will be changed next stream, I swear. It will be a lot less janky. We'll be able to like do things. And also maybe have music. If playback doesn't begin shortly, try restarting your device. Yeah, that's not going to happen. We're not going to restart because we are stubborn. I also turned off my keyboard so I could plug in my tablet for this. So, you know, that's what's going on right now. Let me see if I can like just put on some other something. Mario Sunshine for the win. Later, we're going to do like parametrics. Oh, you got an art tablet? Oh my gosh, Umbra, that's so exciting. Which one did you get? I didn't see that. No, I like haven't been on Twitter as much. Okay, maybe YouTube is just being a piece of poop. And I don't have any music like on my computer. Otherwise, I would have played Tulip because I downloaded Tulip, but maybe I do. Maybe I do technically have Tulip. Whatever. Oh my god. Oh my god. Okay, here we go. It's fine. This is intimate Damie stream. You're here for the You got it for an absolute steal? That's awesome. I'm so happy. I love it when people get art tablets. They're actually probably my favorite thing for computers ever. Okay, how many seconds are in a year? That's easy. I'm really low on the mic. How low am I? It says I'm in like 10 decibels. Wait, let me play stream. I recorded something. I'm gonna be so mad if I'm low. Is it because of my noise canceling? Bro, wait a second. If I'm on max on my phone and I can barely hear you, Let me play this real quick. Oh my gosh, my computer. What is happening? Oh my... I'm sorry, I've been so low. How do I... Why is it so low? It's telling me I'm literally in 10 decibels. Let me just record something real quick. Ba 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 ba. Oh my god, my computer is like not having this either. It does not want to play anything. Oh boy, oh geez. Dudes, maybe oh my god. Okay, I'll just turn up my gain. My gain is at 30 decibels. What? Is it my noise suppression? Like, here. What about that? Does that fix it? My noise suppression is so... Like, I cannot tell you how. Oh, is it... Oh, maybe it's because... Is your mic on Windows maxed? I think it... I can check. I'll do that. I don't... Dude, I'm so pissed at stream right now. Like, not like you guys or anything. It's just... it's so annoying having to move computers because I had a really good setup, like, at home, and now it's just all ruined, especially because I'm on a laptop. Volume? Wait, what? Microphone. Oh my god, is that better? Did that change it? That could not have changed it. That could not have changed it, right? Yeah, that's using that. I mean, I don't really know what else I can do. I'm at like 94. Wait, I'm at 90. Is that better? I don't know. I literally don't know. I don't know what it's probably my noise compression or something. I don't even know if this is gonna like play back for me. Just nothing runs. Just really low. Yeah, I don't fucking know what's up with my computer, dude. Oh my god. Okay. Yeah, it basically won't play any videos. Oh. Wait, I can disable my OBS preview. It says my CPU's only at 3 point... Okay, this is a troubleshooting stream now. Let me see. Where can I find my... like, it shouldn't be really... Wait, let me re-enable that. That's not gonna do anything. It says my CPU is only at 6%. How can I check my... like, my CPU usage? View system resource usage. Basically just everything in general. Oh, whoa. 48% memory? Is that why? Let me just see. Oh. I don't know. Maybe I'll have to mess with some settings. Oh, size, sadly. I mean, it's my OBS and my VTube Studio that are doing anything, you know? But... Okay, well, we can do some more math. I don't know. I can try and turn up my gain louder, but I literally don't think I can... It only lets me turn it up to... I mean, I can turn it up on my output compressor, but that's, like... Is that gonna work? Did that work? Okay, really? Okay. Okay. I wish I could play some music. Silent Damie. You know what? You know what? That's fine. That's fine. I'm normal. I'm normal about it. I'm not sad at all, I swear. I wish I could play music, but like, you know, kind of slay, I guess. I'll have to do... I don't know why. Yay! I don't know why it's doing that. I'll just change settings and stuff. I might need to turn my VTS down as well. Okay, how many seconds are in a year? Chat, let's that's so much. It says I'm peaking my mic in OBS. I'm gonna trust you, Umbra. If it gets way too dank during the VOD, then that's Umbra. That's on Umbra. Okay, seconds in a year. 1 year. Well, okay, there's 365 days in a year. No, put that on the top. Oh my god. A little frazzled. 13.5 million, I think. You're probably right. Days. 31. We'll see. If you want to guess in chat. 24 hours. 1 days. 13 million too small? Yeah. Hours. 1 hour is 60 minutes. And then 1 minute is 60 seconds. Equals. Let me get an eraser real quick. I need like more USB ports. 1 days. I just need to actually properly set stuff up. I did not realize it was going to be this bad to set stuff up. Okay, time to multiply. We love a little multiplication. 365 times 24 times 60. Go back. 60 times 60 is 31.5 times 10 to the 1, 2, 3, 4, 5, 6. Whoops. Wait, I lied. Don't do this. Let's do 3.15. I love the electric mic noise. That's not the electric mic noise. That is definitely my computer fans. 2, 3, 4, 5, 6, 7. 10 to the 7th. Points for anyone who said this. Nah, it's data signal noise? Oh, bro. Does it sound bad? Oh, I hate not streaming with my... 3.17? I don't know where you're getting 7 from. There's 360. It's cute. It's very on brand. Okay, I'll trust you. 8 furlong. Okay. Did I say 31.7 what? 31.7 what? 3.15 times 10 to the 7th. Little different, little different. Okay, that's part A. If one micrometeorite strikes each square meter of the Earth each second, how many years will it take to cover the moon to a depth of 1 meter? Okay, let's read that again. If one micrometeorite strikes each square meter of the moon each second. Okay. How many years will it take to cover the moon to a depth of 1 meter? To solve this problem, you can consider a cubic box on the moon, 1 meter on each edge, and find how long it will take to fill the box. Huh? Wait a second, wait a second, wait a second, wait a second. Okay. A cubic box on the moon. What? 1 meter on each edge? What is a cubic box on the... How is that possible? The moon is a sphere. Would you not want to just do like... The moon's a cube. I mean, I know I've been playing so much Minecraft, but like... It's not a cube. What? Wait. How am I... Wait, I guess I could just like copy and paste this. I guess I could put a screenshot in. Put a screenshot in. Here you go, chat. Here you go. Here's your food. Wow, that didn't work. Awesome. I love it when things don't work. Okay, fine. Okay, fine, clip. If you don't want to work, that's fine. Okay, they are working. Where are they going? Also, I sent pics to the damie cord. Oh, yay, okay. Okay, what is this saying? Bro, what is this saying? My brain, like, can't comprehend, like, what this is asking me. Oops, wrong enter. I have 2 keyboards. I'm so awesome like that. Okay. Okay. If one micrometeorite strikes each square meter of the moon each second, so we need the moon surface area, right? I guess. Moon SA. And we know the diameter of the sphere. It's asking if Damie is gay and looks at the moon. Is the moon gay? Yeah, so true. It is. We love her. So we need, I guess, the volume of MM, right? But then to solve this problem, you can consider a cubic box. What the fuck would a box be if it wasn't cubic? Ah, yes, here's my 2-dimensional box. It's such a box, you know what I mean? It's such a box. It's not just a square. I swear it's a box. On the moon, 1 meter on each. What the heck does this mean? Oh, rectangular? Wait, you're so right. Wait, but what? Am I going like stupid? Am I going insane? How does this solve it? Like, okay, sure, you can say how fast does it fill up. So if you consider a cubic box 1 meter on each edge, right? The box is 1 box equals 1 box times, you know, 1 meter cubed. All right, we have that. Then we want to see like how fast, I guess, it takes to fill up a box to the depth of, okay, so the volume of a micrometeorite would be what? It's like 4/3 pi r cubed is 4/3 pi. Cubing that would be times 10 to the -18th. Trapezoidal box. Can you have a trapezoidal box? Wait a second, I'm gonna turn on some lights. It's getting dark in here. I'm getting a little too mole rat like. Oh wait, let me ping my let me ping my little friends too. I forgot about that real quick. We'll do that in here. Okay, blatantly misspelled it, but you know what? That's okay. So wait, I'm so confused. Okay, I might just like ask him about this in class. I'll be like, hi, I don't understand what you mean. Although I guess because you can say then like 1 box, you can just divide the moon by the boxes, like how many boxes would fit on the surface of the moon. Because you know their surface area is like 1 meter cubed. Maybe that's it. Okay, we'll like try and figure that out. Okay, so 1 meter cubed, we have, this is meters cubed. Right? So we have 1, wait. We have 1 meteor. Your teacher is trying to push cube moon conspiracy theories. Dude's playing too much Minecraft. Dude literally doesn't have social media and doesn't use Twitter, but he's on Minecraft and he believes the moon is a cube. He's like, they're projecting one up in the sky. It's not real. That's a fake. He doesn't believe that. Don't. Okay, so for one box, you have the volume of the box, right? Now we need to figure out, I guess, if you have... We need seconds on the bottom. Which is impossible, right? No. What? How many seconds does it take to fill a box with... Okay, so one of these strikes it each second, which means that it's added this much volume every second. If we want to figure out the volume of this, I can't multiply it on the top because then it's going to cancel out with the meters cubed. Also, this is a diameter. Oh, big brain, please. Too big brain. You heard it? Damie cannot multiply. Yeah, actually true. It's fine because my math professor can't count, so it makes me feel a little bit better. What am I supposed to do, bro? Bro. Okay, also, did I accidentally write A twice? No, I didn't. Okay. Let me move this. Let me move this. You know what? This is scuffed Damie stream, no music, POV, you struggle on your problems that are supposed to be really easy. Okay. So first we definitely need this the micrometeorite volume, right? That we know that. So volume is going to be 4/3 pi r cubed. R equals 0.5 times 10 to the negative 6 meters. So then we say 4/3 pi 1.5. Bro, I feel like this stream is so creepy without music. Okay, it's fine. Okay, that's my camera app. Oh my god. POV, Damie's stream quality gets way worse. Okay, 0.5 10 to 5. Okay, 0. Times 0.125 times 10 to the negative 18th. There's a negative there. You know, normal behaviors. Erase that. Post haste. All right. So this is our lovely equation here. Just saw this, but you can consider a cubic box on the moon and find out how long it will take to fill a box. Okay, so we want our units to be in seconds, right? We want seconds. Want seconds. Per box? Do we want seconds per box, chat? What do you think? Like, one box per 1 second or something. No, I think we just want seconds, because we just want to say like, oh, if we have a box, we just want seconds. Okay. So we have one box, right? We start with one box. That's the easy part. Now, the volume of a box. That's also easy. One box is 1 cubic meter. Now, if we have a meteorite thing, right? 4/3 pi 0.15 times 10 to the... Wow, this is like I'm writing in like runes. Times 0. Oh, B. It's not B. Whatever, it's P. 0.15 to the negative 18th meters cubed over 1 second. Oh, wait, I just didn't... Bro. How long is it gonna take? Dude, it's gonna take like 40 fucking years to fill up the whole moon with these. It's gonna take like 5 million years. Okay. Sure. It's 1 divided by 4/3. 4/3. Whoopsies. Divided by 0.125 divided by 10 to the -18th. That's not going to give me the right thing. Basically, I want to just do the first part. 4/3 times pi times 0.125. Okay, that's... Wait, that's pi over 6? Oh, I'm smart. Okay, so we just have 6 equals 6 times 10 to the 18th over pi seconds. Is that a lot? Let's figure it out. It seems like a lot. What's 6 divided by pi? Like, probably like close to 2, right? Yeah, 1.9. So 1.90... 1.91 1.91 times 10 to the 18th seconds. Awesome. That's how many seconds it takes to fill up one box. I put the gasket on the wrong way and had to undo and redo it. Oh, Umbra, it's okay. We can struggle together. How are 4 people watching me do this, bro? 4 people. Ah, yes. Damie doing unit conversions. My favorite part of the day. Okay. You know what? I'm not complaining. Okay, we need the surface area of the moon. SA of the moon. What if it gives me the wrong moon? Whatever. Okay, it is 37.94 million square kilometers. That's awesome. But we want it in meters. So, SA moon equals, what is that? 37.94 km squared. So we need this in meters. It's just me 4 times. Aw, I love you, Umbra. I need to make a little Damie heart emoji. Emoji, bro, what is this? Apple emote. Okay, so a kilometer has, if we have 37.94 kilometers squared, what do we put on the bottom, chat? I'll give you a hint. You put a 1 on the bottom. Just love the... Sorry, I just looked over. I saw I had the thing up that still says I'm technically playing music, but it's just silence. Oh my god. Okay, now we're normal. Okay. At 1 kilometer, it's kilometer on the bottom, equals 1,000 meters. So we just can add... Wait, I forgot the million part. It's not 37. It's not 37 kilometers squared times 10 to the 6th times 10 to the 6th. So we just add on 3 extra things. So 37. We'll do this. 3.79 times 10 to the... So we're going to add the extra 3 first, and then we add another one. So 10 to the 10th. Over nothing. It's meters squared. Okay. So now we know that we want S for years. So we want to go from the surface area of the moon. So we have 30.79 times 10 to the 10th meters squared over 1. It's going to give us how many boxes? We know we have 1 box is 1. We'll just do this first. 1 box on the top. So 1 box is 1 meter squared times, now we have this other thing, which is 1 box fills up in 1.91 times 10 to the 18th seconds. Now we want to go, there's 60 seconds in 1 minute. there's 60 minutes. In 1 hour, there's 24 hours. In 1 day, and there's 365 days in 1 year. And that should technically give us the answer unless I literally messed everything up, in which case, you know what? I'm going to ask someone in my class or go to office hours and be like, hey, can I level with you? What the fuck was up with this problem? Okay. 10 to the 10th. Just gonna put that in there. Times 1.91 times 10 to the 18th. Getting a little bit big here. Okay, divided by 60. Divided by 60. Divided by 24. Divided by 365. Oh. Oh. Wait. I was like, oh, that's not very long. Here we go, chat. You want to take guesses? You want to take guesses on how many years this would take? 2.2954. So I'm going to say 9. I'm going to leave it as 9. You want to take guesses, chat? 10 to the what? It's pretty big. Okay, I'm just gonna tell you, it's 10 to the 21st. 10 to the 2nd is a century. The Earth has been, how long has the Earth been around for? Let's just see. How long has the Earth been around for? Okay, the Earth has been around for 4.5 billion years. And billion is only to the 9th. I'm pretty sure. Billion power of 10. Yeah. Yeah, so this is like 2.5 times the entire history of Earth, of our universe. Awesome. I mean, that does make sense because it's a micrometeorite, you know? Like, they're not big. They're really small. That's so tiny. Oh my god. Well, we did it, chat. It's like half the time it takes for Damie to stream next. Oh, you're calling me out. You're calling me out. I'll probably stream on Tuesdays and Thursdays. That's probably what's gonna happen. If not, then I don't know. I'll figure it out. I actually might... Yeah, I definitely need to take a day to fix technical difficulties because not being able to play music is not awesome. Not gonna lie. Also, I need to fix my Wacom. Might actually, you know what? This is Scuff stream, so let's just calibrate the Wacom. Why not? I don't have anything better to do. I like to be doing math. Storm's not here. Mapping, please. Mode, area screen, monitor 1. No, monitor 2. Okay, this is like so much better now. Wait, I kind of need to be able to... Okay, my mouse can go over. But the tablet just does it over here. Okay, we'll try that. I don't know. You're gonna see my... Look how much my handwriting was stretched out at the beginning. Okay, what's next problem? Let's see. I gotta save this before my entire work gets deleted. Awesome. It's fine, I would be able to check the VOD. Oh, maybe I should unlist the VODs for these type of streams. I don't know. My physics teacher is like more, yeah, definitely not. If you are in my class, I will have to block you. But you're not, so it's fine. You know what? I love all you. It's fine. Okay, starting from a pillar, we get to draw something. Finally, chat. My favorite thing to do, drawing. Okay, starting from a pillar. Let's draw a pillar. Let's draw a really nice pillar. Getting used to the angle that I'm sitting at as well. Okay, here's our pillar. Got some grass. Okay, beautiful. Lovely. Starting from pillar, you run 200 meters east. Okay, so we're gonna run 200 meters, just like dot, dot, dot. 200 meters. I'll draw a little fucked up person, if you will. Oh, that looks scary. I don't like that. We're gonna draw like a cuter person. Yeah, there we go. At an average speed of 5 meters per second, all right? 5 meters per second. Then we run average the other way, 280 meters west. Oh, past this, you know how it be. To 80 meters. At an average speed of 4 meters per second to another post, but that's fine. Okay. Pigeonholed myself a little bit there by not reading it. Calculate your average speed from pillar to post. Your average velocity from pillar to post. Okay. Average speed is defined as, let me scroll down a hot sec. Okay, I'm scrolling. So intensely scrolling. Okay. Average, where's my average speed here? Yeah, velocity. Average speed is distance traveled over time interval spent traveling. So distance traveled. So A is going to be, where'd it go? Average speed and average velocity. So one will be a scalar. So av speed equals dist traveled over time taken equals, so dist traveled is going to be 200 meters plus 280 meters, and then time taken is going to be 5 meters per second times, we get rid of the, wait, how do I want to do this? So we have 5 meters per 1 second, and we say this is, we ran 200 meters. That'll give us 1 over seconds. That'll give us 1 over 40 seconds. That seems right. Well, can I say like 1 second per 5 meters? I guess I could say that, right? Let me turn down the brightness on my computer a little bit. Hopefully I can get a mic arm at some point as well, because I'd love to not have bad posture, but, you know, maybe I'll put it on my throne or something. You guys know that app? Maybe? Okay, whoa. Okay, yeah. Average velocity is a displacement over time, so that'll be a different thing. So average speed is distance over time. If we want to know how far it took us to get 200 meters, oh, I can just flip it. My bad. I'm so smart right now. Actually, it's so weird going back into some of this stuff because, like, I have not had to think about this in a long time. Okay, that really does not like that. I wonder if that's just my nib or that particular spot. It probably is my nib. Yeah, it's my nib. Okay. Okay, yep, 40 seconds. So 40 seconds plus, we did 280 meters at 1 second per 4 meters, which is 28 divided by 4. Why is it eluding me? 7? Yeah. 70 seconds. Yeah, so we ran farther and it took us longer. We ran slower and farther, so 70 seconds. So we got 480 divided by 110, which is going to give us 48 over 11. 11 meters per second, which roughly comes out to 4.3 meters per second, which I think is pretty normal for a human to run. Let's see, human run speed in meters per second. Yeah, 5, a little bit less than 5. I mean, our first one was 5 and our second was 4, so it makes sense that it's going to be closer to 4 than 5 because we ran 5 for less time. At less distance, I guess I should say. And then our average velocity is going to be velocity equals displacement over time. So this is going to be displacement. We basically only went 80 meters, negative 80 meters over still 110 seconds. So that's going to be negative 8 over 11 meters per second. Nice. Whoa. This is not due for like a week, but you know what? I'm doing it today, so getting some of the headache out. Let's see. How does that feel? Does that feel right, chat? What do you think? What is that? That's 8 divided by 11. 0.7. I mean, to be fair, yeah, your velocity is like the change in displacement, so. Okay. I have like 19 problems to do. Is that a lie? Do I have 19? I think I have like maybe 19. No, I have 14. Okay. If I can get through half. It's just like, I gotta turn my brain on, dude. Not have to think about stream issues. Okay. A car is stopped by a traffic light, travels along a straight road so that the distance from its light equals bt squared minus ct cubed. Okay, calculate the average velocity. Oh wait, we're doing problem 6. Wait, what? Did I skip a problem somehow? Did I just write 5? Okay, this is 5. Oh my god. I'm so smart. It's fun. We get to do some calculus though. We get to do some calculus though, guys. Everybody loves a little bit of calculus. 6, okay. So on a 20-mile bike ride, you ride the first 10 miles at an average speed of 8 miles an hour. What must be your average speed over the next 10 miles to have average speed for the total be? Okay, 2 different things. So A. So we have a 20-mile long. Wow, oh, I think it's because my hardness is too high. So our first average speed, what did that say? 8 miles an hour? Yes. 8 mi an hour. So if we want our full speed to be 4 miles an hour, right? So av speed equals 4 mi/hour. That means that, so we know our total distance is going to be 20 for both ways because we're not doubling up, over the time it takes, right? So 8 miles an hour. So we're going 10 miles at 8 miles an hour. That's going to give us 8 over 10, which is 5 over 4. Yeah, 5 over 4 hours. So that's going to equal like an hour and 25 minutes. But we can leave it in 5 over 4 hours. So we know that we have to have 5 over 4 hours plus x, right? So that's our other time. And to get this time, what we did was we put we know it's going to be 10 miles, right? An hour times some y, or we can just say x, because, you know, and we know it's going to be, we want it to be equal to 4. So this will have to be, yeah, this will have to be 1 hour, right? Because that's how you measure time. So if we rearrange this, x equals, or like 10x equals 1 hour. So x equals 1 over 10 hours. Wait, what? How fast do you have to go to do that? Wait, what? That's not true. That's not right. That's not right. Huh? That's definitely not right. What's going on here? 10x equals 1 hour. I feel like I'm like doing this a little bit silly. Because x's are, oh, x's are, okay, I am silly. X's are miles, so 10 miles times x equals 1 hour. Right, so x's are miles per hour. So if we want to, how do we want to substitute this in? I should call this y, probably. No, what we should do is we should solve for this other x first. Oh, nice. My CSP history just deleted. Oh, there we go. So 20 miles plus x has to equal like 4 miles per hour. So that means that 20 miles equals 4 miles per hour. If we divide the 4 over here, this just becomes 5 equals 5/4 hour plus x times an hour. Okay, this might be a sign that Davey's getting a little tired here. What's happening? Let me think. Sometimes you just gotta think. Okay. Delete everything. All right. 4 miles an hour. We know the average speed is the distance traveled over time taken, so that's our 20 over, you know, our full t. So we need to get the other one first, right? So from 10 miles, right? This is going to be our 8 miles per 1 hour, and this is going to be our 5/4 miles per hour. Oh wait, no, this is just 10/4 hour. I'm 5/4 hour. I'm big brain. 1.25 hours. plus x, right? So x is our other time. Now if we say 10 miles over 1 times 1 hour over y, this is going to equal our x, right? And we know that 20 miles, this is supposed to equal 4. So now if we combine these two, we can say 20 miles over 1.25 hours plus, we can multiply this out too, 10 mile hours over y equals 4. Maybe. Is that going to play nice with literally anything? The answer is probably not. Let me think. This is how I would do it. We get like 20 miles equals 4. Well, 1.25 times 4 is going to be 5 hours plus 4 times 10 mile hours over y. But we can still get rid of things, potentially. You know, if we just brute force it, right? 20 miles minus 5 hours equals 40 mile hours over y. It might end up working out. Let's see. Sometimes I overthink physics too much though, so y is going to equal, so we flip everything over. That means you're going to be multiplying probably 40 mile hours over 20 mile minus 5 hours. Does that give us anything? What if I multiply this by... No, I don't think that's gonna work. I don't think that's gonna work. Sage. Well, okay, you know what we can do? You know what we can do, chat? We can do a little bit of parametrics. Oh, I forgot the keyword doesn't work. And then I can figure out what the fuck is wrong with my computer. I could stream, like, not right now. Let me save this. I'm gonna call this problems PHYS, or 141 PS1. And then this is a thing. Don't care about that. Okay, awesome. Let's do some parametrics. Why not? These don't even need to be like, these don't even need to be down on paper. I'm just doing them for funsies, just for the funds. No, they kind of do. I don't know. I was at like 600, page 700, I think, 740-ish. Yes. Okay. A little bit more, like 716, I think. Keeps reloading my textbooks. Okay, what was one that I was doing that kind of sucked and that I was doing wrong? I was doing, oh, you know what we can do? We can do the one that I got really wrong. Okay. So we need to find, yeah, this might be better for me to take a little screenshot of. Windows Shift S. Here we go. All right. Find the parametric equations for a path of a particle that moves along the circle. X squared plus, oh my gosh, it's Clem! Hi Clem, how's it going? I'm so sleepy, tired, and my mic is bad and everything is bad, but I'm normal. Maybe. I don't know what's wrong. It could be just because there's a lot of echo in the, I don't fucking know. Okay, I'm gonna try and do this problem. It might like fail, but that's fine. So I'm gonna start by doing x equals, help, we sleepy, so true. I feel like I've already started picking up an accent from people around here. Okay, so we're gonna do x equals sine of t and y equals cosine of t. Easy enough, right? Okay, now we want to add the radius because this is a little circle, cute little circle. The radius of the circle is going to be 2. Because remember, in this thing, it's always squared, so everything's squared. So we gotta put a 2. So it's gonna be 2 sine t, 2 cos t, and then we just want to move the y up 1. So this will be 2 cos t plus 1, and we got 2 sine t. Okay. So for A, we need to do once around clockwise, starting at 2, 1. So let's just like draw our little thing first. So we know we want to start at 2, 1, which is right here. We know our circle is going to have a point here, a point here, a point here. Right, because we translated a circle at the origin just like up 1. That's not a very good circle, but we're gonna go with it. We're gonna go with it. You know what? That's as good as I can do on a tablet that it's not coordinated for me. Okay. So what if t equals 0? What do we get? Well, sine of 0, if I just draw like a little unit circle, sine is up and down. So sine of 0 is going to give us 0, right? So that just makes the whole thing 0. And then cos is going to give us 1, so that'll be at 0, 3. So 0, 3 is going to start us up at the top here, which we don't want. So we want this to be 2, which means we want sine to be 1. So where's a place that sine equals 1? Well, at pi over 2, sine can equal 1. So if we do pi over 2, we're going to get 2, and then 1. So we know that t has to start at pi over 2. Now we just want to go once around clockwise, which is this way, right? So if we want to go once around clockwise, that's periodic. So that would be 2 pi, right? Because it takes us 2 pi to go around the whole circle. So that would be 2 pi equals, right? 4 over 2 pi. So 5 pi over 2. Now we just have to check. Well, we're also going to check on Desmos because of course we are, but we want to figure out which way we're going, right? So if we go this way, when we do like pi over, let's say 3 pi over 2. So we're starting here, we know that. If we do 3 pi over 2, we're going to get 3 pi over 2 is, so this is 1 pi over 2, this is 2 pi over 2, this is 3 pi over 2 down here. That means our sine is going to be -1. So we're going to get -2 for the x. And we're going to get 1. No, I lied. We're going to get, are we actually going to do, wait, what? -2, oh, that's here, yeah. So we're going counterclockwise. We're going this way right now, which is not how a clock moves. So I think all we have to do is just change this to a -t. I think in here, but let's like check that. Let me pull up Desmos real quick. me pull up Ledesmos. I mean, my music still is stupid as hell. Awesome. Love you. I love you, YouTube. I don't know what you're doing, but we love it, I guess. Maybe. You know, I hope at least this can be some good math cringe ASMR. Like molding at math and ASMR. We love it. So true. It is ASMR? Okay, that's good. It's Damie story time. It's late. Wait, Clem, it's so late where you are. Isn't it almost like 11? So I'm sorry for giving you up. Wait, the microphone is popping? Oh my gosh. You should sleep. I'll read you a story, bedtime story. About the cubular moon. Here, I'll read some quiet story time. It's no surprise that, during a given time interval, a speeding bullet travels farther than a speeding snail. To extend our study of motion so that we can compare the bullet to the snail, we need a way to measure how fast or how slowly an object moves. One quantity that measures an object's fastness or slowness is its average speed, defined as the ratio average speed equals distance traveled over time interval spent traveling, d over delta t. If you drive 15 miles in 30 minutes, your average speed is 30 miles per hour. Although the concept of speed is widely used in our day-to-day lives, it is not a sufficient basis for a science of motion. To see why, imagine you're trying to land a jet plane on an aircraft carrier. It matters a great deal to you whether the aircraft carrier is moving at 20 miles per hour to the north or 20 miles per hour to the east. Simply knowing the boat's speed is 20 miles per hour is not enough information. This is really tempting to fall asleep to. Do it. Do it. Do it. Do it. You won't. I can read my... Oh my gosh. Wait, do you guys want to hear my engineering textbook? It's so bad. It's so bad. I read so much of it already. What's a good quote from it? It's like... Oh my god, this is the best part. And you're trying to kick me out, cruel. Okay, let me just read you something that's gonna laugh. Okay, so I have to take this class. It's called ME 163, Mechanical Engineering 163. And it's called Orientation to Mechanical Engineering, right? So you're supposed to kind of like learn about jobs that mechanical engineers do. You're supposed to. This is the textbook that we have. 1.2. What is success? I assume you want to be successful. I hope that's why you're reading this book. But just wanting to be successful is not enough. Everyone wants to be successful. Often when speaking to an introduction to engineering class, I'll ask the question, how many of you want to be successful? All of the students raise their hands. It's so bad. Oh, it's so bad. It's so bad. Where's the part where they tell me to... Wait, where is it? Where is it? Sigma grind set. It's so bad. It's so bad. Oh my god, this is so bad. I love this. I love this. It's literally... The most likely reason you will fail to graduate in engineering is that you will encounter adversity and give up. You will have difficulty with a course or professor. You might have a personal problem. Whatever adversity you're bound to experience, you'll be tempted to use it as an excuse or justification for quitting. Don't! That's the whole thing. It just says don't. Oh, you have a problem? Not anymore. Don't. Just stop. Just stop doing it. Just stop failing. Oh, it's so bad. It's so easy, dude. Just don't fail. Just don't do it. Oh, it's so much skill issue. Skill issue. You're so right. Skill issue. Oh my god. Wait, my lights are turning off. Oh wait, I have to get up and like kind of move around. There we go. I fixed it. They turn off with motion sensing. I haven't moved enough. Let's see. What else? What else is this? Oh my god, these are so bad. I can't believe I read all this. I read like 66 pages of this. I'm not even gonna lie. it's so it's so old. It's like, you may get a job for $8 to $10 an hour now. Bro, this clearly was written like 20 years ago. Anyway, I meant to put on Desmos. Let's switch over to Desmos. Let's let you guys see Desmos. Why not? Here you go. Have a little Desmos in your life. Have a cute little Desimos. Oh, crop it down a bit. There we go. Okay, that was not ASMR. Sorry, my mic fell off my table. I just saved you from falling off a cliff. You're welcome, chat. Oh my god. Oh, this stream is so scuffed. It's fine. It's fine. It's fine. It's fine. It's fine. Okay, let's put in the equations. Okay, here's a little trick. Here's a little trick. If you want to write things in Desmos in a parametric equation, you can just you can put it in parentheses here like this, and it'll do it actually. So we started at like what, pi over 2, right? And we went to 5 pi over 2. Okay, so that makes a circle. We did that well enough. Now if we change this to 3 pi, it's going to give us counterclockwise, but we want it to be clockwise, right? So, because what we know is like, we're starting at this point, and if we go there, how are my Crush girls doing? Clem, I'm gonna be real, I've not played Crush since I moved. I need to get back on the grind. Whoa, that's not what I wanted to do. We're just gonna encapsulate these t's in a little parentheses. What the fuck, fake? Yeah, I am fake. If we put a minus here and a minus here, okay, it does nothing. I was not expecting it to do nothing. Okay, how do we get it to switch? How do we get it to switch? What if I put a minus here? If it does nothing, I'm so pissed. There we go. We fixed it. We fixed life. So then we just put a minus here. There we go. Or I guess I could just say like minus t in between. Oh, I need to change my screen. There we go. I'm tempted to just do ASMR physics reading on one of the parts I haven't read yet. What do you think, chat? Even though we didn't get through all of chapter 1, and he told us to read chapter 2 by tomorrow. But it's fine. Okay, I should? Okay, we're gonna do it. Here, I'll switch screens. Wait, let me see where I... Okay, we're gonna do a little calculus. I love that. I love that. Wait a second, let me show you. It actually says, like on this, it calls it a little calculus. It's so cute. It just says like a little calculus derivatives. Here, I'll zoom in. A little calculus. A little calculus. Okay, where was I? Finding position from velocity. No, I did that. Integrals, we talked. Maybe not. Maybe I didn't read this. Let's see. I'm not going to read that because that's kind of hard to read. No, I actually did read that also. Okay. Motion with constant acceleration. We need one more major concept to describe one-dimensional motion. Acceleration. Acceleration, as we noted in chapter 1, is a rather abstract concept. Nonetheless, acceleration is the linchpin of mechanics. We will see very shortly that Newton's laws relate the acceleration of an object to the forces that are exerted on it. Let's conduct a race between a Volkswagen Beetle and a Porsche Beetle to see which can achieve a velocity of 30 meters per second in the shortest time. Both cars are equipped with computers that will record the speedometer reading 10 times each second. This gives a nearly continuous record of the instantaneous velocity of each car. The velocity versus time graphs based on these data are shown on the next page. How can we describe the difference in performance of the two cars? It's not that one has a different velocity from the other. Both achieve every velocity between 0 and 30 meters per second. The distinction is how long it took to change its velocity from 0 to 30. The Porsche changed velocity quickly in 6 seconds, while the Volkswagen needed 15 seconds to make the same velocity change. All right. Yeah, what part is good to read here? Let's see. So that's just a little bit about acceleration. Okay, we can talk about this. This is cute. So a basketball player starts at the left end of the court and moves with the velocity shown in figure 2.20. Draw a motion diagram and an acceleration versus time graph for the basketball player. All right, so we're going to do this just kind of thinking about it. Right, so we need an acceleration versus time graph. We know that acceleration is the change in velocity, which means that it's the change in velocity over time, right? So how much velocity is changing over how much time is changing. It's actually the slope of the line. So from 0 to 6, our slope is going to be, our acceleration is going to be 1 meter per second squared, because that's what we're in, meters per second per second. Then from 6 seconds to 12 seconds, this is a positive acceleration, by the way, which means that they are speeding up. Then the velocity is going from, actually let's go from 6 to 9, right? So when our velocity is positive, our acceleration is negative, right? Because the slope of the line is negative, and that's going to be, it's going to be 6 over 3. So that's going to be, we're decelerating at half a meter per second. Wait, no, 2 meters per second. And then at this point, our velocity is at 0, right? So we've stopped. And then we're going to be going in the opposite direction. And we're going to be accelerating because our velocity is negative and our acceleration is negative. So if we look at this over here, we said that initially we're going to be going, we're at a positive velocity, we're moving to the right. Then we start to slow down, right? That's this part right here. Then we turn around because the signs match up. So it's under the graph and it's negative. That means that it's gonna be accelerating even though the acceleration is negative because the velocity is negative. Which is kind of cute. It's kind of slay. Oh, yeah, you can see that. Okay, let's see. So, oh, this is so exciting. The kinematic equations of constant acceleration, right? So this is, we can have a couple different scenarios. We can have constant velocity, right? Which means, or let's say acceleration is 0, right? That could be a statics problem. You're talking about something sitting on a desk or, person standing or some fluid doing something, right? Nothing is moving. Or you can have a constant velocity, which is 0 acceleration as well. So if a ball has reached if a ball is falling off a building and it's reached its terminal velocity, which means that it cannot physically speed up anymore, then you have constant acceleration. Right? Or in simplified free fall problems, you often have constant acceleration. That's a lie. I said constant acceleration. Free fall does not have constant velocity. Okay. So consider an object whose acceleration remains constant during the time interval delta t. At the beginning of this interval, at time t, the object has initial velocity. Note that the initial time is often 0, but it does not have to be. We'd like to predict the object's final position and final velocity. So what we can do is, okay, this is a little proof. We can go through a proof. So we know that the object's final position is the initial position the final position equals the initial position plus the area under the velocity curve, right? So you can do this with calculus. That can be the integral of velocity, or it can be, you know, just algebra out if you have that possibility. So because when we have constant acceleration, right, that means our velocity is going to look like a line, which means that it's always going to make some sort of trapezoid or triangle. It's not going to be like a funky function everywhere, which means that we don't have to do any fancy integrals, so we can have a nice equation that will always work. So that's why this equation will always work, right? But once we get into different accelerations and this graph starts to look a little different, we have to use integrals and some more complicated stuff. Or, you know, it's just a case-by-case sort of thing, right? They would have to show us what it looks like. We can't just say, oh, I know what the velocity is, like, I know what the acceleration is or whatever. But this is like something, you know, if we have a constant acceleration, that would be a free fall problem. That would be, you know, maybe like a car problem, like a lot of trains, planes, that kind of stuff. All right. Well, let me turn the brightness down. All right. So yeah, basically, we're just going to be substituting things in. So they said the final position equals the initial position, which is the area under the velocity curve, right? So 1/2 base times height. They're just doing the triangle, this part of the triangle. So 1/2 times, oh, they're doing, that's the 1/2 base times height part. This part is this VIS T part is the, just, you know, the VIS is the height. And then the distance is T, right? So, and then you can just do a bunch of math. You have a question? Yeah, what is it, Umbra? Oh, that's my mail. Don't dox me. I'm so smart. Thermodynamics of heating up chili. I actually had to do a lot of those. There's a surprising amount of those problems in guess we made pork wontons. Ooh, I'm so jealous, dude. That sounds so good. You gotta send one to me, okay? Here, I'm gonna switch over to clip real quick. I don't know. What do you guys want to do? We could do physics. We could do math. We could go to sleep. Question completely ignored. Well, okay, give me a problem. Do we want to say, okay, let's say this. But you didn't give me something to like solve. Like, what do you want? Do you want like a time up to a certain temperature? That's pretty easy, right? That depends on the material property. Do you want maybe what do people normally do? Normally the problems are like if you heat it up at a certain rate like this, then when it cools down like that. No, I lied, the other way. It cools down like that. I don't even remember, because there was thermo problems we did for calculus, but the thermal problems I did were like, a lot of it was like, you have a container, right, of a certain amount of gas, and you compress it either quickly or slowly. This is the gas. And like you can compress it either quickly or slowly, and like what happens, like how much energy is transferred. Or something like you push this piston down, then you put the flame on, like it's on like a burner or something, right? Like a candle. You put the flame on, then you slowly raise the piston up. Or sometimes it would be like, oh, it's in water, right? The gas is in a water. And there's a flame under, no, there's not a flame underneath. There's force being added from the top, and Yeah, something like that. This is probably the best. This is probably the best of all three, though. I think I might, you know what I think I might do? Because I don't like how scuffed this is. I don't want to stream when stuff is super scuffed just because I feel like it's a worse experience for me and for you guys. So I think I'm going to wrap it up here and eat. I might do a poll on Twitter that I will post in the Discord to see like what times work for you guys. Because I could do this. Oh, you have a question. I'll answer it. I could do this. So I have a period like that's completely free from like 6 to 8. Oh, I need my live reaction to your tablet. Oh, did you post pictures in the server? I'm not going to bed, but you should go to bed, Clem. Let me see in the server. Oh, XP pen. Oh my. Oh wait, I saw you mention this. Oh my gosh, that's so awesome. I don't have a screen tablet. Those are screen tablets, right? Wait, why was that $24? What? Clem's sleeping. I tuck you in and give you a little head pat, Clem. That's crazy. Did they like accidentally market the wrong price? Bro, that's awesome. They were like, yeah, 1/10 the original. Oh no, it was a great loss for us with this low price. Oh, that's so sad. But I mean, like, it's awesome you got a tablet. I need to like set mine up better. I need to change all my settings on clip and stuff because I don't have any of my brushes. I don't have any of my anything. I wanted to share it with you, but you were away. Aw. Yeah, I was away. I was moving. It took a... Oh my god, my orientation stuff was like so long. Oh my god. I literally only started classes yesterday. So... yeah. Alright. You guys are awesome. Thanks for staying with me with the scuff stream and the peaking mic, and I'm gonna be so mad if this audio sounds worse. But I don't even know. My computer can't play videos, bro. I'm gonna have to do some stuff to figure out how to make it better. I'm also gonna try and like put my computer in like a drawer, I think, or like farther away. But I'll do some checking on the sound quality. All right, love you guys. I'll see you Thursday or earlier. Probably not earlier, just because I think there's so much stuff to fix. But love you. Bye.